All right, 8.4, finding sums of infinite geometric series, 8.4. So this is going to be the formula for the sum of an infinite geometric series right there. Boom, 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 boom. First of all, what the heck is an infinite geometric series? Well, here's a series right here. There's a sequence, these numbers, there's a pattern there. There is. We're adding them together. That means it's a series. And now at the end of this, when it has these three dots, the ellipses, these three dots means that pattern goes on forever, okay? Those three dots goes on forever. That means that's an infinite geometric series. Here's another case, infinite geometric series. This is the pattern. The lower limit's 1, the upper limit's infinity. That means this pattern goes on forever when the upper limit is infinity, okay? It's gonna go on forever. When you see an infinity there, it goes on forever. Excuse me. So now let's take this and use this formula. The sum of an infinite geometric series, that's infinite right there. So sneak that word infinite in there. This formula right here, a sub 1 is the value of the first term. A sub 1 is the value of the first term. You've seen that before. R is the common ratio, and this works only if the absolute value of R is less than 1. If the absolute value of R is equal to 1, or if the absolute value of R is greater than 1, then the series has no sum. Means that won't work if that's the case. Okay, so let's practice. Put this into practice. What we got here? Blah, 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 blah. Okay, well, we need this right here. First of all, we need the value of a sub 1. A sub 1, and we need the value of R. What's the value of the first term? The value of the first term is 4. R, this divided by that, 4, 3/5. 3/5. R is 3/5. Okay? R is 3/5. There we go. We have those two bits of information. Now we have to see, does this apply? Is the absolute value less than 1? Is the absolute value of that less than 1? Yes. Means we're going to get a sum. Beeping. So the sum, the value of the first term is 4. 1 minus 3/5 is 4. 1 minus 3 is 2/5 equals 4 times the reciprocal times 5/2 equals 5 to 10. So if you take this plus this plus this plus this plus this, you're going to get 10. Okay? Going to get 10. So basically what they're doing here in this, let's use this as an example, this right here. They're saying if you take the value of the first one, you get some number. You add the first 2, you get the next number. If you add the first 3 terms, you get the next number. The first 4 terms, you get this. The first 5 terms, you get this, then this, then this, then this, and this, and this. This right here starts doing this. And it starts approaching a number like your gluteus maximus, a word that comes after Jack. Asymptote. It looks like an asymptote right there. It's approaching, this number right there is approaching that number right there. So in this case, an asymptote, this is not technically an asymptote because this actually will reach 10. So, but it's getting right up there to 10. So in this particular case, that's going to be 10. The sum is going to be 10. Next one, what about this? What here? What do you do? So we need to find these values. Okay, what's the value of a sub 1? Well, I know it's infinity because the upper limit's infinity. So the value of the first term, k is 1. 1 minus 1 is 0. That to the 0 power is 1. Times 3 is 3. First term has a value of 3. R, that's your R. If you want to find R, you can find the first 4 or 5 terms and then find the value of R, but that right there is a formula for the geometric sequence. Okay, and that's R, so it's 0.7. Now, is the absolute value of R less than 1? Yes. Back means we're going to have an answer. We'll find the sum of the infinite geometric series. So the first value is 3. 1 minus R is 0.7. Okay, now move that up a a little higher so we can see it. There we go. 3, and that's going to be 0.3, and that is 10. What? Same answer? How did that happen? Wow, that's also 10. Answer 10. Boom. Next one. C. We have it right here. 1 or 2. Dot, dot, dot means it's infinite. So we need the value of the first term, and we need R. The value of the first term is 1. R. Looks like it's times 3, times 3, times 3. R is 3. So does this work? Is the absolute value of that less than 1? No! The absolute value of 3, is it less than 1? Nope, it is not. Therefore, sum does not exist because of that. Okay, because of that, sum does not exist. We're done. We're not going to get a sum. Letter D is in David. Delta. Delta. Delta Dawn. Okay. By the first term on R. First term. Value first term is 1. R. Times 3/4 times 3/4. That's 3/4. But it's alternating. Ooh, it's a negative 3/4. R is a negative 3/4. So 1 times a negative. So it's getting negative, positive, negative, positive. And we have the 3 dots. It means it's infinite. So does this apply? Is the absolute value of this less than 1? Absolute value, negative 3/4. Is that a true statement? Absolute value of negative 3/4 is 3/4, and yes, it's less than 1. So we're going to be able to get a sum out of this. So the value of the first term is 1. 1 minus negative 3/4 is 1 over 1 plus 3/4 is equal to 1 over the 7/4. 1 times the reciprocal. 1 times 4/7. Bada bing bang boom. There we go. So that's your sum. So these are alternating. And basically what that's doing, and that's alternating, you're saying, okay, I'm going to have a sum 1, then you're subtracting 3/4, and you're adding 9/16. You're saying, I'm going to get a number here, then I'm subtracting a number, then I'm adding a number, then I'm subtracting, and so this is kind of doing something like this. Something like this, and it's getting, these are getting smaller and smaller and smaller. We know that because this right here, because of this right here. If it's less than 1, for these alternating positive, negative, it's doing this, and it's getting smaller. And eventually, it's just going to go. Okay. So yes, that'll work, and we get that. That was the answer. Next one, last bit right here is a little different. Write as a fraction in simplest form. Hey, this right here, you could also write it as 0.24242424 dot, dot, a dot. You can write it with the repeating decimal, or you write that way. In either case, that means it's repeating or it goes on forever. That means it's repeating. It goes on forever. Okay? So we can say 0.24 plus 0.1224 plus 1, 2, 3, 4. 1, 2, 3, 4, 2, 4 plus 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 2, 4 plus dot, dot, dot. Hey, there's our pattern. We just change it from this into a pattern we just did, repeating. And what's the value of a sub 1 and what's the value of r? The value of the first term? 0.24. 0.24. R, what's R? Take this and you multiply it by 10, 1/10, 1/100th. 0.01, it's 1/100th. So we're moving it 2 places over. 1/100th, 1/100th. So there are our numbers. Is the absolute value of this less than 1? Absolutely. Bam! We're going to get an answer. So plug the numbers into that formula. Boom. And value of the first term is 0.24. 1 minus r, 0.01. 0.99. That's the same as 24 divided by 99. Can we simplify that? 3, does 3 go into this? 9 plus 9 is 18. Does 3 go into 18? Yes. 4 plus 2 is 6. Does 3 go into 6? Yes. They're both divisible by 3. So 3, 33, 8. And we get that. And can we divisible? Can we divide it any further? No, we can't. That's it. Verdonskis. Oops, there we go. Bada bing, bang, boom. So if you take this and write that as a fraction in simplest form, you get this right there. Bada bing, bang, boom. That's it. Hasta la bye-bye. See you.